Right, so Pythagorean identities, this is how we can remember some Pythagorean identities. If we forgot them and we can calculate, well, we can compute them. So let's say we have a graph. This is a line, this is the origin, and this is point P. Point P is x and y, x-axis, y-axis, and r is the distance from point P to the origin. So I rewrote it, but whatever. It's r is a distance from the origin to point P, so both can make sense. So let's go ahead and find out a way to compute these Pythagorean identities. So we need to know that, remember that cosine of theta is equal to x and sine is equal to y, right? But we have the r, we have the distance. So in this, according to our graph here, cosine of theta is equal to x over r. Let's go ahead and find sine of theta. Sine of theta is equal to y over r, right? Because sine is y over r. Y over r. So now we can use this to compute some trigonometric identities. So let's go ahead and use the Pythagorean theorem. In this case, r is going to be our hypotenuse. It's not going to be c. So this is going to be y and this is going to be x, right? So let's go ahead and compute. Let's go ahead and use the Pythagorean theorem. So we have x squared plus y squared is equal to r squared. So a squared plus b squared is equal to c squared. So now we replace it with we replace it with the values that were given here in the graph. So x squared. So let's go ahead and divide all of this. Let's just go right here. So we have x squared plus y squared equals to r squared. Let's go ahead and divide all of this by r squared, sorry. R squared divided by r squared. So now we have x squared divided by r squared plus y squared divided by r squared is equal to 1. Right? So now let's go ahead and do this. Let's go ahead and x over y squared plus y, oops, that's an r, by the way, I'm sorry about that. That's an r. Y over r squared is equal to 1. So we see here that x over r. What is x over r? We established that x over r is equal to cosine of theta, right? And y over r is equal to sine of theta, right? So this gives us cosine squared of theta plus sine squared of theta is equal to 1. So that's how you can remember this trigonometric Pythagorean identity, by doing this one. This by just computing, just divide everything by r squared and just use what you know here and a little bit of algebra to find this one out. So we can use this to do some trigonometric identities and stuff, and yeah, that's what we can use that one for. So let's go ahead and let's find another one. So let's start again with x squared plus y squared is equal to r squared. So let's divide x squared by all of them. X squared by, let's divide everything by x squared, sorry about that. So let's divide everything by x squared. This is equal to 1 plus y squared over x squared is equal to r squared over x squared, right? So this is equal to 1 plus y over x squared is equal to r over x squared. So I know I did not write it down here, but I'm gonna assume you guys already know that. If not, then that's okay. We can just learn it right now. Y over x, that's sine over cosine. And what is sine over cosine? That's equal to tangent, right? So just in case you didn't already know, but I'm not really going to go too much in depth in this video. I'm just assuming you already know. Sine divided by cosine is tangent. So this is going to be tangent squared. 1 plus tangent squared theta. Right, so this turns into tangent squared theta is equal to, oops, we have r over x. We do have r over x. We have x over r right here. We take its reciprocal identity. So 1 over cosine, that is secant, right? Again, if you didn't know that, that's okay, but 1 over cosine is secant. So just so you know right here. So this is going to be secant squared theta, right? It's going to be equal to secant squared theta. This is just its reciprocal identity. So here's another identity we can use. That's another identity you might see in your trig class and the one we can use. So in case you forgot it, just do this little computation. Know what tangent is equal to sine divided by cosine. Know what the reciprocal identity of cosine is. So the reciprocal of cosine is secant, right? And the reciprocal of sine is cosecant. Just so you know that. Just have that already memorized. Plus, it's crucial for if you're going to take a trig class to already have that memorized, and the calculus class, and so on and so forth. So let's go ahead and let's do another one. Again, let's start with x squared plus y squared is equal to r squared. So we divided everything by r, we divided everything by x. Let's divide everything by y. Y squared divide everything by y squared. This is going to be x over y squared plus 1 is equal to r over y parentheses squared. So x divided by y. So here's another, I don't know if I mentioned this earlier, but here's another identity. Cosine divided by sine, which is a reciprocal of tangent, is going to be cotangent, right? So there's going to be cotangent. Cotangent squared theta plus 1 is equal to r divided by y. So again, we have sine, we have y divided by r. So the reciprocal of sine is going to be cosecant, right? So I have cosecant squared theta. So it's important to already have the reciprocal identities memorized. I mean, they're easy, they're not that hard, and it's important to know what tangent is, what cotangent is, and so on and so forth before we can start memorizing some trig Pythagorean identities. So this, you might see it as 1 plus cotangent squared theta is equal to cosecant squared theta. So 1 plus cotangent squared theta is equal to cosecant squared theta. Yeah. So this is another trig identity that you can see in your trig class, and you're going to be using it to do some computations. So that is how we can memorize these. If we forgot, we can just do this computation from the graph right here. Use the definitions of sine and cosine, and yeah, that's it. That's how we can compute them. And there we go. We have our 3 trigonometric identities.